Good morning, everyone. This is Ms. Cruz, and for today's math class, we're going to be doing standard A3 for 5th grade. Compare two decimals to the thousands based on meanings of the digits in each place using the greater than, equal, and less than symbols to record the results of comparisons. So when we're comparing decimals, we think of which ones are larger and which ones are smaller, which ones are greater than, which ones are less than, or which ones are equal. If we look at the image below comparing decimals, we can also think of them as if we put them on a weight scale. So if we have 5.38 and 5.32, and we put them on a weight scale, which one of our decimals would be heavier? Well, if we look at our digit in our hundredths place, we have an 8 and a 2. 8 is greater than 2, meaning it is heavier. So 5.38 is heavier or greater than 5.32. Let's look at our decimal place value system. For today's lesson, we are going to be using our ones, our tenths place, our hundredths place, and our 1,000th place. Let's talk about our symbols. We know our greater than sign has the opening that points towards the biggest number, and the closing side of the symbol points towards the smallest number. We've also been taught that the alligator wants to eat the biggest digit, or the biggest number. So the alligator wants to eat 15 and turns its back on 12, meaning 15 is greater than 12. We've also seen this sign, and that is our equal sign, which means the two decimals we are comparing are the same or equal to each other. Let's compare using our decimal charts and base 10 blocks. We have the numbers 2.781 and 2.209. If we write these down in our decimal chart, we'll see that when we get to our tenths place, 7 is greater than 2. If we need more help, let's look at our base 10 blocks. In our ones place, we have 2 base 10 blocks for each number, our decimal point, and then we move to our tenths place where we have 7 base 10 blocks, and then 2 base 10 blocks. We can see by using these blocks that 7 is greater than 2. So 2.78 is greater than 2.209. When will I compare decimals in real life, you say? Well, let's think of decimals like money. Our dollars are going to be in our hundredths, tenths, and ones place, and our cents, coins, or change are in our tenths and hundredths place. So let's say we're at the grocery store and we want to buy a candy bar. But we've been saving our allowance to also buy a video game. So we want to buy the cheapest candy bar. So we compare candy bar A and candy bar B. Candy bar A costs $1.50. Candy bar B costs $1.55. You see how we can use the decimal points to relate to money, so our dollars, and then decimal separates our whole numbers from our fractional part, so the dollars from the cents, or our change. So if we're going to buy the cheapest candy bar, we would buy candy bar A. So candy bar A is less than candy bar B, but I'm sure it tastes just as good. We could also use a number line to figure out which decimal is greater and which one is less than. Sometimes we may get confused because some decimals have more digits after them, but that does not necessarily mean that they are greater. 9.25 has more digits after the decimal point than 9.7, but if we look at a number line, 9.25 is on the left, 9.7 is on the right, meaning 9.7 is greater than 9.25, or 9.25 is less than 9.7. Let's practice together. 3.02 compared to 3.20. That's right, 3.20 is greater because we have a 2 in our tens place instead of the 0 in our tens place. Let's look at 9.5 and 9.50. That's right, they're equal to each other. Lastly, 7.3 and 7.276. This is where we can get out our number line to see which number is on the left or which number is on the right. 7.3 is greater than 7.276, even though 7.276 has more digits after the decimal point. You guys did an awesome job.